question 4, we have to show that x squared plus 6x plus 11 can be written as x plus p squared plus q. So that's asking us to complete the square here, because you can say it's something squared plus a little bit. P and q are integers to be found. So for A, I think I'll write it up here. If we're completing the square, it's something squared. You have to have x to be able to get x squared. It tells you that anyway here. And then you look at the coefficient of x, which is positive 6, and you just half it. And that way, when you multiply it out, you would get x squared. You would get 3x plus a 3x, which would give you the 6x. You would get 9 when you multiply this out, and we want 11. So if it's 9, you just need to add 2. And that's it completed there. P will be 3, it's this number here. And Q will be 2, this number here. And that's it. That's just completing the square. If you multiply that out, it would give you this. We'll probably have to use this next. Let's have a look. Part B. You have to sketch the curve with the equation y equals x squared plus 6x plus 11, showing clearly any intersections with the coordinate axes. Now, we probably will need this, but we'll just go this, complete the square version. But if you're going to have a graph, and it wants to know anywhere where it crosses the coordinate axes, well, we've got this, or this up here. We'll use that in a minute. If we want to find out where a graph cuts the y-axis, we let x equals 0. And we can do that with this one or this one above. We'll just stick with this one. When x equals 0, nothing, y is 11. So that graph there must, when x is 0, y is 11, it must cross here. Now to find out where it cuts the x-axis, we have to let y equals 0. So we're solving 0 equals x squared plus 6x plus 11. So we'd usually factorize this, but this will not factorize. You will not be able to split this up and have something that times us to make 11, but adds to give 6. So it won't factorize. That doesn't mean that there's no solutions. So you could use the quadratic formula, but we've already got the square version. We've already got x plus 3 squared plus 2, which is exactly the same as this. So if we try and solve that here, anytime you're solving an equation that's in the square form, you take away this number, you put this over at the other side, so you're left with x plus 3 squared equals -2, and then the next step is where you take the square root of both sides to undo this squared bit. We can't take the square root of this negative number, so there will be no solutions. So if there's no solutions, that means this graph cannot cut the x-axis, so it must be a floating one. It either cuts through here, or it looks like this here. But we don't know, because we don't know any places that it crosses the x-axis, because it doesn't. So the way we find out is by looking at the minimum point, the lowest point on the graph. If it's here, then we know that it's along like that. If it's here, then we know the graph looks like that. It's really easy to find the minimum value when you've got completing the square, when you've got it in here. The minimum value of this whole function must be when this bit inside the bracket is 0, because as soon as it's not 0, when you square it, it has a value plus 2, you've got a positive value there. So the minimum value this function could take is when x is -3, and then you'd get -3 plus 3, 0 squared plus 2. So the minimum value is actually 2, and it happens when x is -3. So when x is -3, y is 2, the minimum value must be here, so therefore the graph looks like this. Minimum value, really easy to pick up from there. So that's part B, sketch the curve with the equation, showing clearly any intersections with the coordinate axes. We don't have to show the coordinates of the minimum point, but I've got them there so we could see it was on the left hand side. Part C, we have to find the value of the discriminant of this. Well, we know it's going to be negative because we couldn't get any solution before. We can't solve the equation, but we'll find the value of the discriminant for part C. We can write it small. The discriminant is the bit under the square root sign in your quadratic equation, b squared minus 4ac. In this function here, a is 1, b is 6, c is 11. So we get 6 squared minus 4 times 1 times c was 11 times 11, which gives us 36, subtract 44, which gives us negative 8, therefore negative. We don't have to write this bit. Just showing you it backs up what we said before. Find the value of the discriminant, you've done it there. Sometimes part D does ask you to talk about why, what this means in terms of the graph. Does this back up what sketch shows? And yes, it shows that it doesn't cut the x-axis, there's no solutions. It hasn't asked us on this one here, bizarrely enough. So that's it there.